is John Black, Super Chemist. This is not an instructional video. It is just a vlog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk. You see it, the front came up to new front on there. And it jumped like from 70 degrees all the way up to 110 almost here, and it's still climbing. So that's why I switched it over. You can see it's still not coming over, but it will in a second. There goes one. First drop, 2 drops, 3 drops. So I'm just going to collect. Yeah, it was like 70C for a while, and then it dropped. It was going down to 65. The steelhead I'm talking about. So what I did was I jacked the heat up, and when it started coming over again, it looked like a new front was coming. And as soon as it hit the front, hit the thermometer, bam, it jacked up the heat. 112 degrees Celsius, that is the boiling point of nitroethane. But you can see how nice and clear, super water clear it looks. Still got almost a half a 50 milliliter flask, so that's, hopefully we'll get 20 mils out of this. This flask right here is a 25 milliliter, so I know I'm not going to fill it all the way up. If I did this experiment enough where I got a whole mole, I would throw some magnesium sulfate in there or some calcium chloride and dry it up and redistill it. I'm not going to redistill this little bit of amount and dry it up. Okay, so here's the equation, your molar masses, molar volumes, that goes for that. Now the ethyl bromide, I used one mole, which is 74 mils or 75 mils, whatever I used. The silver nitrate, I used 175 grams instead of 154 because I wanted to have a little bit of excess. The way you can tell that you're done is by taking a little sample and putting it in some ethanolic silver nitrate. And if there's any precip, that means that you still have ethyl bromide left and the reaction isn't done. So this is my limiting reagent, or what I would figure out my yield with. I have 1 mole here, so I should have 1 mole here if I got 100% yield. I got 19 milliliters. Divide that by what I should have got, and I end up with 27% yield. That was my yield. Now last time I got a 6% yield, okay? So I almost 5 times or 4.5 times multiplied what I got last time. You know what I mean? I improved big time. 27% sucks, but being that it was my second attempt only and I did improve, I'm happy. What would I do to improve this method? It obviously sucks. One thing is I started for 3 days like you're supposed to, but the last 2 days you're supposed to actually start in room temperature. My thinking is, though, is the reason you start at 0 degrees is because the hotter it is, the more you make the ethyl nitrite as your byproduct. And you don't want that. You want the nitroethane. So you start in the cold for the first 24 hours. But my way of thinking is why do you start, if that's true, why start at room temperature at all? My thinking is the only reason you would do that is that you would want to speed up the process, because once you only have a couple molecules of ethyl bromide left, that didn't react yet, they have to go around and find the silver nitrate that's left, you know what I mean? And not only do they have to find each other, they have to hit each other exactly right. They have to smack into each other. They can smack into each other a million times, but they have to do it exactly right for the reaction to take place. And it must be hard for that to happen. But my thinking is if you do that, you're just basically burning up all your ethyl bromide, making ethyl nitrite instead of nitroethane. So I started in the cold. That might have been a problem, though I might be wrong. Maybe I would have got a better yield by putting it in the room temperature while stirring. I don't know. I didn't do it, so that's that. What would I do next time? I would do this experiment the same exact way, but next time I would add in more ethyl bromide. The reaction's never done, okay? So there's no sense checking. You have to just pick a amount of time you're willing to sacrifice to stir, you know what I mean, and that's that. Next time I would sacrifice 1 day to stir it. And I would add in, instead of a mole, right? Instead of a mole to a mole, I would add a mole of silver nitrite and let that be the limiting reagent. And the ethyl bromide, instead of 1 mole, I'd put 2 moles. Maybe even 2.5 moles, 2 to 2.5 times more than the silver nitrite, you know, molar-wise. Because it seems like, well, if they can't find each other, just throw in a bunch of extra more ethyl bromide. That way they, you know, it's easier to find, it's easier for the silver nitrite to find an ethyl bromide if there's 2.5 times more in there, right? Even after you used up 90% of the silver nitrite, you'll still have a mole and a half left of ethyl bromide. You know what I mean? It should be able to get a better yield that way, I would think. I don't know why, since it is such a tough reaction for these to happen, I don't see why they're having, I mean, I do see why they have this as the limiting reagent, so that you can test to see if you're done. But you're never done. You're never done. You know what I mean? So, anyways, that's my yield. Two other things I wanted to bring up was, one, I was wrong about the color. In the first video, my first attempt at doing this reaction, the Victor Meyer reaction, I got done stirring, was in the middle of stirring, and the yellow silver nitrite turned into gray. I assumed that was the silver bromide. I assumed silver bromide must be gray. This video, I looked it up, and it's actually a pale yellow. Silver nitrite is a vibrant yellow, you know, like almost a dark yellow. But the silver nitrite, it's the same yellow tint, but it's much paler. You know what I mean? Almost a white yellow. So I was wrong about that in the first video. Keep that in mind. Because of the light, my stuff didn't turn gray this time. It stayed yellow the whole time. Even though I didn't put much light on the first reaction, when I stirred it, you know, a lot, or I had it sitting there a lot, there was always a little crack somewhere in there where I didn't get the aluminum foil all around it. You know what I mean? I wasn't as careful as I was this time. This time it was in a closed room, and I turned the light off. There was no windows, no nothing. I only opened it up at night, and I, you know, put aluminum foil all the way over it a couple times each time when I stored it. And the second thing I wanted to bring up was, and I'm guessing, I think the azeotrope of nitroethane and water is 87 degrees Celsius. This reaction, I really didn't, it just jumped. It spiked way over there. You know what I mean? It spiked from 70 degrees all the way up to 110, and then eventually went up to 112 after a milliliter of distillation. So you might as well say it went right up to 112. That's the boiling point of nitroethane. There was no water in it, although there might be trace amounts, you know what I mean? And that's why it came over to 110 there for like a millimeter or two. I know there wasn't barely any water in it because the azeotrope boils at 87. So if it boils at 87, see, 110, that's almost the boiling point of nitroethane. That's way above. There's no water in it almost. If I had maybe a mole, let's say I did this experiment a couple times and I had a whole mole, you know, 70 milliliters, I'd probably get some drying agent, molecular sieves or whatever, throw them in there for a day or two, or, you know, calcium chloride, magnesium sulfate, whatever, and then filter it and redistill it so that I'd make sure it was really dry. I don't have enough to do that, but I just did want to let you know that the azeotrope, you know, if you think you have water in there and it spikes up to 87C, you know, if it did that, I would bring that over with, I would distill from 87 all the way up to 118 degrees Celsius. I'd take that, I'd be like, oh, that's definitely got a lot of azeotrope in it. I would throw in some drying agent, filter it, and redistill it. Okay. Mine didn't have any water in it, so I didn't really have to worry about it. Last time I did this experiment, there was some water in it. I don't know how, but it seemed like there was, from the way it distilled over. But I didn't accept any of that. I should have taken some of it, and my yield would have been more. You know what I mean? I didn't, any part of the azeotrope, I wasn't thinking back then that there was an azeotrope. You know what I mean? I knew it, but it didn't register. So therefore, anything from 87C, which there was stuff that came over from 87C up to, 110 or 112 or whatever, that I discarded. You know what I mean? So I probably got a better yield than 6% or whatever it was, 5%, but not much. So anyways, it's, like I said, if I did this again, I would definitely just throw in 2 or 3 times as much ethyl bromide as you have silver nitrate. I mean, that way it's easy for them to find each other and bump into each other the correct way. If it takes a million times to bump into each other, to do it the correct way once, hey man, instead of 70 milliliters, throw in 200 milliliters. I bet they'll hit each other eventually a lot faster, And ethyl bromide boils at 38 degrees Celsius. So you can easily boil it up, compare it to the 112 to 116 C that the nitroethane boils out at. So I also wanted to mention that I'm trying to sell t-shirts to see if this channel is even worth continuing with. So I got about 30 logos, and I'm trying to put about 50 more logos up, meaning different designs. This is one of them that I'm wearing, Mad Scientist, JBSC, and it has Mad Scientist on it. So before I try to do Patreon or whatever, I want to see if I could sell some of these t-shirts. I mean, if I go all summer and I only sell like 2 t-shirts, obviously the channel is a flop, and there's no sense continuing. But here's a couple designs. And not all of these shirts are about science, although most of them are. Some of them are about other stuff. But if you want to see the designs, or buy a t-shirt, you just want to check the designs out just to see what they look like. I'll leave a link in the description below the videos. Now there's not just t-shirts with the logos on it. You can also get leggings, coats, hoodies, stickers, ashtrays, tapestry, posters, magnets. There's a million things that they sell there that would have the same logo on it. Tote bags, there's so many things I can't even remember. And my buddy is also, Old Man Ramblings, is also selling me t-shirts. So I'm going to leave a link to his channel and also his t-shirts. So if you really want to help the channel, buy a t-shirt. I mean, they are expensive, but it's to help the channel out. And either way, whether you buy a shirt or not, have a great day, and always remember, science is great.